Okay, so on your desks, you should have the blank template to this note. We are going to be talking about multiplying and dividing monomials. Some of you, it'll be very familiar with this as you've done it in grade 9 and 10. If you're coming from the applied stream, this may be a little bit new to you and you're definitely going to have to work at getting this skill. So the first thing that we're going to go over is a review of the exponents laws. And this is basic exponent laws, and you should all be familiar with this. So I have my first example here, and I've kept it pretty general to apply it. Right now, I have x to the exponent a times x to the exponent b. So you're going to notice here that I have two parts to this that I'm going to be talking about. That x is referring to the base, and the little a is the exponent. Okay, so I have here as part of the definitions, when we multiply like bases, so I have xa times xb, when they are like bases, I just write the base x and then I add the exponents a plus b. So I'm going to go over two basic examples here of using this principle. When the bases are the same, I add the exponents. So my first example here, I'm going to have a basic one, and then you'll notice that it gets a more complex one with coefficients, which are the numbers out in front. So I'm going to look here. I have a base A, and I have a base A. Those bases are the same. So what am I going to do? I'm going to add the exponents together. So I can write this as a to the exponent 4 plus 2. Now, do you have to write this step? No, you do not. But I'm going to just go through this to try and break it down step by step. My next one, I also have an x to the exponent 5 and no x there. Now, when I have two variables like this that are beside each other, that means multiplication. So I'm not going to add in any addition sign or multiplication sign. So I'm going to write a to the exponent 4 plus 2, and then I have x to the exponent 5. Now, similar to when there's no coefficient out in front, when there's no exponent, it always means the exponent 1. So 5 plus 1. So my final answer for this will be a to the exponent, what's 4 plus 2? That gives me 6. X to the exponent, 5 plus 1 gives me 6. That is my final answer. A and x are not like bases, so I can't add those exponents. Now you can go right from this step to this step. I don't expect to see that middle step. If you need to write it, then you need to write it. But I'm expecting that you can be able to go from this first line to the last line. Okay, the next example we have is a little bit different. Why is it different? Because now I have coefficients. So when I have coefficients, I just do the operation that it says to do. This is saying -5, and this is in brackets, so brackets mean multiplication. So I'm going to take that -5 and I'm going to multiply it by 2. So I take -5 times 2 gives me -10. Then I look at my bases. I have an a here and an a here. So what will I write? Well, I know I'm going to have an a, and then I can write 2, because that's to the exponent 2, and the exponent 4. So 2 plus 4 gives me 6. I then look at my b's. I have a base b, so I know I'm going to have some b's, and I take 3 plus 7. Well, I can do that math. 3 plus 7 gives me 10. And that's my final answer. So when I have coefficients, I just do the operation that it says to do. When I have like bases and we're multiplying, how do I know that we're multiplying? Again, brackets mean multiplication. I just add the exponents, and then we're done. That's how you would do that example. Okay, so now we're going to go, so we just did multiplication, now we're going to deal with division. So I have here as general rule, x to the exponent a divided by x to the exponent b is equal to, what do I do here? I subtract the exponents, a minus b. When we divide like bases, we subtract the exponent. So it's the opposite of what multiplication is. So I'm going to go through two examples here. I have m to the exponent 4, m to the exponent 2, so I know I'm going to have an m. What do? I do 4 subtract 2. So again, I'm writing out this in-between step, and I'm hoping that you don't have to write it. Again, I have a letter n, so I'm going to write n. I have an exponent 5 here, so I'm going to write 5. And there's no exponent there, it means the exponent 1, so I'm going to write 5 minus 1. What do I do next? I simplify my answer. This becomes m to the exponent 2, n to the exponent 4. Okay, the next example here, again, why is this one different? I have coefficients here. So what do I have to do? I have to take care of my coefficients. This is saying 8 divided by negative 2. What do I get when I do 8 divided by negative 2? I can type that into my calculator, and I get negative 4. I look at my bases, k to the exponent 9, k to the exponent 2. So again, I subtract, those are the same bases. So I subtract the exponents, 9 minus 2 gives me 7. So my final answer for that is equal to negative 4, k to the exponent of 7. Okay, those are basic examples. We're now going to look at maybe some more complex examples. Okay, here I have 3 terms, 1, 2, 3, and what am I doing with all 3 of them? I'm multiplying. It's saying 2k times negative 3k squared times 5k to the exponent 5. So first step is I'm going to multiply all of these coefficients together. 2 times negative 3 times 5 gives me negative 30. So I'm going to write negative 30. Now I'm going to look for bases that are the same. I have a k here, a k squared here, k to the exponent 5 here. Remember that k, just k has an exponent 1, so I'll now write base k, and what I do is I have to add all the exponents together. 1 plus 2 plus 5 gives me k to the exponent of 8. Okay, when I go to my next example here, again, I have some coefficients, so I'm going to take care of my coefficients. Negative 18 divided by negative 6. When I plug that into my calculator, negative 18 divided by negative 6, I get positive 3. Now I look at my bases. I find like bases. I have a b cubed here and a b to the exponent 1. Well, I'm dividing, so I know I'm going to have a b. When I divide, I subtract my exponents, so that's a 3 minus 1, which gives me 2. I then find similar bases again. I have y to the exponent 5, y to the exponent 4, so I know I'm going to have a y. I'm dividing, so again, I subtract my exponents. So I take 5 minus 4, which gives me 1. My final answer is 3b squared y. And do you have to put that exponent 1? No, if you do, that's okay. Okay, we're going to go over some more examples. Here, again, this one is very similar to the one we just did. Now we just have double bases, whereas in this example here, we just had a single base. Okay, so what am I going to do here? I have multiplication. 3 times 2 times negative 5. I get negative 30. I find similar bases. I have x to the exponent 1, x squared, x to the exponent 3. So I write x. I then take 1 plus 2 plus 3, which gives me 6. I'm going to look for other similar bases, y squared, y cubed. So I write y. I'm multiplying, so what do? I add the exponents, 2 plus 3, which gives me 5. Okay, the next example, this is This is a bit of an interesting example, one that you can definitely expect on a quiz. I have a lot of operations going on here. I have multiplication, and I'm saying 3x squared y6 times negative 4xy divided by 2xy to the exponent 5. My first step here is I'm going to break this up into steps. I'm going to take care of my numerator first. I'm going to make that into 1, so it becomes something that looks like what we did on the other page, where I just have one numerator, or one term on the top, one term on the bottom. Then it will become easier to divide. So I'm going to start here. I take my coefficients, 3 times negative 4, which gives me negative 12. I have an x squared, an x to the exponent 1 here. So what do? Those bases are the same. I know I'm going to have an x. Then I'm going to take 2 plus 1, which gives me 3. I look for another base, y. There's an exponent 1 there. So I know I'm going to have a y. 6 plus 1, which gives me 7. And I'm going to keep my base, my denominator the same. I haven't touched that. I'm just simplifying my numerator. 2x, y to the exponent 5. Now my second step, well, I will be simplifying this piece here. So I'm going to take my coefficients again. Here are my coefficients, negative 12, 2. I'm going to divide. Negative 12 divided by 2 gives me negative 6. I then have an x3, an x, that would be to the exponent 1 here. So I know I'm going to have an x, so I take 3 minus 1, which gives me 2. I have a y7, I don't know if you can see that, a y to the exponent 5. I know I'm going to have a y, and then I do 7 minus 5, which gives me 2. So my final answer is negative 6x squared, y squared. Okay, our last two examples that we are going to look at, again, this is a pretty straightforward one. Please remember, when there's no coefficient, it means the coefficient 1. I'm going to try and get that in blue, 1. So I can take negative 2 times negative 1, which gives me positive 2. P to the exponent 3, and then I have a p, there's no exponent there, so that means 1. So I know I'm going to have a p to what exponent? Well, I add 3 plus 1 gives me 4. Okay, and another similar example to the one we just did. Again, we're going to simplify the numerator first. We're going to make that all into 1. So I look at my coefficients. Negative 3 times negative 2 gives me positive 6. I look for similar bases. X squared, x. Again, there's an exponent 1 there, so I know I'm going to have an x. 2 plus 1 gives me 3. I have a y and a y squared, so I know I'll write y. Again, there's an exponent 1 there, so 1 plus 2 gives me 3. All over negative 6x y squared. That stays the same. Okay, so I still have to simplify this further. I'm going to take care of my coefficients. 6 divided by negative 6 gives me negative 1. I have an x cubed on the top and x to the exponent 1 on the bottom, so that gives me x squared. A y cubed on the top, a y squared on the bottom, which gives me y. So I can have negative 1x squared y. Do I have to write that negative 1 there? You don't need the actual number 1, but it would be, you could also write this as
please page extension 2306.
negative x squared y. Okay, so you are going to work on the attached worksheet to practice that for the remainder of the class. If you have any questions, please star them and let me know, but this homework is expected to be done.